Okay, right, hello and welcome back to another video. So today we're going to be having a brief overview of the material editor course that I've been working on for the last 12 months or so. So if you've been following the channel, you'll have seen these sort of courses get released step by step, but now that they're all finished, I want to do a big overview of all the things that are available. So it's a complete Unreal 5 materials course. Starting out with the basics, we cover even the UI and the node types, exactly everything from ground up. So if you've never touched Unreal, you've never used materials at all, everything will be covered. But we really go in depth as well. So we're going up to advanced visual effects materials and post process and really quite complex things by the end of the course. It's 35 hours long and covers maybe 200 or nearly 250 worked examples. So we won't be covering every single one in this video, but hopefully I can give you a bit of an overview and show you the structure and the breakdown and how the course is structured. So with all of my courses, I try and not just sort of give you a few tutorials to follow, a few step-by-steps, try and give you the background and the logic and the theory behind what's happening, so that when it comes to your own materials and your own work, you can take that sort of building blocks and build off that. And so that's really what I've tried to do here. So the first part of the course here, I've called it Material Editor Reference. It is a series of step-by-step tutorials. If you are completely new to it, it will cover everything, but also it's designed to be a kind of reference library as well. So 6 months, 12 months after you've taken the course, if you've got something that you can't remember, you're not quite sure about, you can always refer back to these lessons, and everything's been broken down, so step by step, nice and concisely. So we start with some introductions. As I say, everything from the ground up is included in this course. So what the material UI looks like, what are nodes, how do they work, some of the common node types. All of these materials are broken down, nicely commented, very neatly laid out, and then we'll have corresponding videos to them as well. So trying to make them as usable as possible. So once you've done the course, you can refer back. The notes will just tell you what you need to know, but the first time through, you obviously have that video explaining everything in more depth as well. Cool. Let's do this. Starting with the basics, we then move on to all the different blend modes, explaining what the difference between an opaque material, a masked material, translucency, this kind of thing. Each with their own example, with breakdowns, types of refraction, etc., etc., all neatly laid out, commented. Shading models goes hand in hand with blend modes. When do we use an unlit material? When do we use, I don't know, subsurface, the different types of skin materials you can have. As I say, this is built up as a reference library so that everything is included, and so there's no kind of gaps there in the different blend modes and shading models. Moving on to the math, this is sort of the core breakdown. So there are 25, I think, different material types or material breakdowns in here, different ways of using nodes, combining data, breaking apart data, how to do contrasts, doing animations, sine waves, things like that, all with nice breakdowns and worked examples. Not gonna lie, this kind of section is maybe not dry, but like it's quite factual. And then later on in the course there are more worked examples, so trying to again keep this as a sort of simple and concise breakdown of the different kind of nodes, and rather than having one big video that covers 15 things, everyone has its own video, so it's more useful in the long term, I think. Cool. Again, not going to go through every single one. There's an awful lot in here. So looking at input data, how can we get information from other parts of our engine, things like vertex colors or world normals, pixel normals, vertex normals. How can we take that data and use that to drive our materials? So again, theory part here and worked examples to follow. Cool. Another breakdown, UVs, incredibly powerful way of working, creating artificial gradients or kind of in-engine gradients. Things like tiling and scaling, gradient mapping, flipbooks, animation. Here we've got UV distortion. All of these techniques can be combined together and built into larger and larger materials. And all those will be covered in later parts of the course and the worked examples we have there. So cool. That's part 0, the sort of introduction. If you are new to the materials, if you are new to Unreal, obviously you can sit there and go through every single video, because it's such an in-depth look at all of the different parts. I'm not saying that's definitely the best way to do it. Maybe look at a few and then jump into some worked examples, and you can always come back and use that as a reference library later on. So trying to get kind of double duty out of that. So yeah. Moving on to the worked examples, we start with master materials. So there's an awful lot of ways we can use Unreal's kind of tools to our advantage. So breaking down our materials in such a way that really work for us. So here, nicely commented laid out material works really well, but we could also do the same thing with functions. And so trying to build our materials in such a way that they're not just usable, but also future-proofed and designed for kind of maximum reusability and things like that. So a lot of workflow talk as well. It's not just how do we do things, but what's the best way to do things. Similarly with decals, different types of decal materials, how they're used, where they're used, some more complex decal types at the end. How can we use world space? So we talked about input data earlier, getting information from out of the material. Every object has its own unique position in space. Well, we could use that to drive our materials. You can see here, as I move this object around, things are changing about it. So having exactly the same object multiple times, our scenes don't look repetitive because we're using materials to break that up. Works for objects, things that are designed to be modular kits or kind of like larger pieces. We can do the same thing with projections. So you can see here as this moves, part of the material is being projected onto it, which can help break up larger pieces. We can use world space direction, so here put moss on the side of trees, or maybe using snow on top of objects, and so all dynamic, again just using that information that the engine gives us to power our materials. So a lot of really nice techniques like that, and then some distance based things as well, so normals that only appear as we get close, or the same kind of thing in reverse, materials that are blending between different type techniques, different scaling FUVs to give us a reduction in tiling. And so as I move the camera out, you can see that tiles quite badly, but as we get close to it, another blend comes in. And so again, using information from the camera, camera to material. We have a look at vertex painting. So using vertex colors to drive our materials. Do we just use a soft blend or height map blending? All of this is clearly broken down, adding normal details in the edges. And each of these is clearly commented out and easy to follow, using functions and materials. So even quite complicated materials hopefully get broken down into nicely easy to follow and easy to work with solutions. After vertex colors, we look at landscapes. Give that a sec to load. So this sort of part 1 here, using all of these material techniques in sort of an environment context. How can we build our scenes using these things? So landscapes, vertex painting, object position randomness, those kinds of techniques that can really help add to a scene. Different landscape types. Here, one that doesn't really work. This is a very common problem that happens. We'll explain why it's happened and how to fix it. Here, there's too many texture samples, so it can't resolve the material properly. How can we fix that? Different types of blending, so weight blending, height map blending, and alpha blending. These are the 3 types available in the engine. I'll give you my experience of them all and how I think the best way to set materials up is. Different controls, so using contrast to create different edges between your material blends, using height adjustments, adding modification layers. So here, adding a puddle, doesn't care what's underneath, it just goes on top, as water would. So some nice things like that. Using grass meshes, and then finally using runtime virtual textures. So how do we blend our meshes into our landscapes? There's some nice techniques there in Unreal to do that, which we cover. While talking about landscapes, we look at auto landscapes. So here on the left, we have sort of some debug colors using information from the landscape itself. So height, facing ratio, angles, randomness with textures, all of those things to build up a kind of systemic way of texturing a landscape. And then here on the right, the same thing, but with some materials as well, so some worked examples for that. And then finally, in the first section here, in environment materials, we have a look at the layered material setup. So using the layered materials within Unreal to create more complex shaders, doing our blending within the material system itself. So in part 2, we have a look at world position offset. How can we use math within our shaders to do animation or offsets and things like that. So just the basic setup here, breaking it down with simple grey box materials, how to do simple sine wave animations, whether we're using local space or world space, inflation, that kind of thing, scaling, using a blueprint to drive it. And so, so we can kind of like control exactly how that movement's happening dynamically here. And so on. So again, broken down into nice simple examples to learn the theory, and then going on to some worked examples and some real world settings as well. So here we have a level of various hanging chains and flags, and different ways we've used more and more complex world position offset settings and techniques, simple rotations, etc., into creating these kinds of materials. As always, well commented, broken down, nice and clean and clear, easy to follow, so that you can use these as reference and refer back to them later on. Moving on to more foliage based solutions. So here, little clumps of grass, we want them to move around just back and forth in the wind, using information from our scene here. So have a blueprint wind controller, and I can change things like the speed and intensity to create more dynamic wind for our materials. Taller grasses, so there's a bit of rotational movement in here as well. Ferns have a bit of kind of on-plan rotation as well. Some quite interesting maths to get that to work. So a lot of working with vectors, trying to create different approaches that sort of work with as a realistic type of wind. It's not just moving, but it's moving as plants actually would. Water plants here, just moving up and down with the water surface, and then maybe a sort of slightly more advanced single mesh here, moving back and forth. And again, looking at the math behind all of that and how that all works. And then some other sort of little techniques you can use with world position offset. More advanced techniques here. So we have a camera facing plane. So using the shader to just make sure that we're always looking at the surface here. We can do the same thing with the spline thicken. So drawing out a thin strip of polys, and now they'll always follow the camera around as we move around them. Gives us the illusion of a thick cylinder, but actually it's not. It's just a plane rotating to face us. We have a look at some more complex world position offset here. So butterfly wings, or fish, sort of swimming animations, and then how to use that on something like a particle effect here. And then finally, looking at our reflections and normals. How can we recalculate our normals? Very often when you're doing world position offsets, you're not getting the correct rotations and normals to your thing, and we can build that up into the shader, like so. Last things for world position offset, some more large scale things. So can we rotate the whole world? Yep, totally can. So here we've got a little helper blueprint that's creating this rotation for this spiral. Or we can do something like this, where we kind of fake a planet. So we've got two different techniques for sort of creating that rotation and bending around the world. Okay, that's part 2, world position offsets. Part 3 is VFX. So if I find part 3, starting out with the basics, so just fog planes and light shafts, building up the techniques here really from scratch. Moving on to combustion, so different types of flames and fires, candle flames, some fake smoke plumes, 6 directional lighting, so using a baked light maps and allowing us to have different lighting techniques from different angles. Cover how to do that. Building up a campfire here. Everything is material based, so there's no particle systems for the embers, that's all material. There's no lighting here, that's all material. Using techniques to create the illusion of complex motion, just kind of broken down, which works really nicely. And then finally in this sort of section, it's not really combustion, it's lightning, but it didn't fit anywhere else. So animation again, so using UV animation, vertex colors, all those kinds of things to create this very animated, non-repetitive animation we've got here, all within the shader as well. We have a deep dive into water, all the different component parts, so animated surface with normals, reflection, refraction, opacity, all the different types and ways that can work, breaking it down and doing compare and contrast, looking at different performance costs. How can we do it if we are not constrained by performance? We can use the really expensive ways, and what does that look like, and how can we do it the sort of cheap ways, and what are the trade-offs to that? So talking not just about how to do things, but sort of the performance implications as well. Using some well-positioned offsets, building on those techniques covered in part 2 here to do sort of water surfaces. We look at fixed depth, and then flow maps as well. So here, having a flow map controlling that animation. And then finally, the single layer water, so the new blend mode or shading model that is included in the latest versions of Unreal. We have a quick look at an ocean. Not too in depth on the ocean, it's an incredibly complex material in itself, but how can we do some kind of real-time applicable things for oceans? So baking vertex animation in texture, or using kind of like a volume texture to do some height map controls. We have a look at rain. Realistically, we'd probably use particles for rain, but there are some material techniques we can do as well. So there's no particles here, this is all just materials, which works quite nicely. We have a look at a magic portal, so how can we use sequencer to combine with our materials and do animation. If I open my sequence, nope, that's not my sequence. If I open my sequence, there we go. So building up different types of animation, changing how things are rendering, controls for things like that, size, scale, etc. And then finally, in the VFX section, have something a little self-indulgent. I made myself a Marvel Snap style playing card, but basically controlling different parts of material with different values. So here we have a blueprint that will animate and control the different parts of our shader. So using masks and layers and that kind of thing. Cool, that's everything in the VFX section. Finally, we have the post process section. Again, building up a kind of working knowledge of the different components, different parts. If I can spell post process volume. There it is. And then applying them with some worked examples as well. So talking about the depth buffer, talking about scene color, working out how to build these things up into our materials, and then doing some examples of techniques you might want to use. So we cover pixelation, affecting the screen UVs. We have a look at using depth-based fog. So this is using in the depth buffer to create this kind of fogging effect. Have a look at blurs. Don't know how well they'll be able to see that on the video recording, but now the corners of the screen now are sort of radially blurred, and we can do things like that. The classic edge detection. So here, quite thick lines, but we're picking up the edges based on either the depth buffer or the normal buffer, and doing some comparisons. And then finally, some more in-depth examples. So here, kind of underwater type shader. So looking at color, looking at depth, looking at screen space distortion, all of those things. And then finally, a pencil sketch, kind of using textures and mapping those textures to the scene in post-process. So lots of examples there as well. Cool. As I say, the whole course is about 35 hours. It covers an awful lot in hopefully quite a lot of depth. This is about 10-15 years worth of my experience using Unreal, all condensed down into this course. Each section is available on its own, and there is a bundle, so you can combine them all together and get a bit of a discount if you want to take the whole course at once. I hope you do. I'm very proud of this. I think there's some really good content in here. Hopefully you'll take it and build some interesting and exciting things in your own work. As always, if you have any questions or comments, or if there's anything that needs clarification or anything that you think I've missed, I will be adding to these courses. So I'm going to build up some worked example scenes using these techniques and try and kind of expand on this with more content as well. So do check that out once that arrives. And yeah, hopefully you will give it a go, and I look forward to seeing all the exciting materials and scenes that you make in your own work.